Okay, a couple of people were struggling with this question yesterday. So to help you, first of all, I'm going to introduce some of the basic concepts to you again. So let's just start off by looking at two triangles which are similar to each other. Okay, now remember, two triangles are similar to each other if one is an enlargement of the other. And I'm going to draw them purposefully, to make it simple, with the same orientation. Okay, so I'm having my angles all sitting in the same orientation. Okay, so that means that we've got this angle corresponding to this angle here corresponding to this one here, and then this third angle corresponding to this third angle here. And let's say we've got some lengths on some of this. So let's say that's 3, that's 7 here, and we're trying to work out x, and we know that this one is, let's say, 12. So first of all, we work out what the scale factor is. Okay, so what is the scale factor? So to work out the scale factor, we simply need to divide one of the lengths by the corresponding length. So these two lengths here, so we're going to say our scale factor of lengths, is 7/12. And we know that all our lengths are 7/12 as big as the corresponding lengths on the other triangle. So here, if we're trying to find x, well, x is, remember, x is bigger than 3. Yeah, these lengths are corresponding, and we know that this triangle on the right is bigger than the triangle on the left. So we need to multiply by the scale factor so that it's a number bigger than 1. So we want an improper fraction. So 12/7 times the corresponding length, 3. All right? So that tells us what our x value is. So we're going to get 12 3s, 36/7. Okay, and of course that's, if you want to approximate that as a decimal, you can, but typically I wouldn't put that as a decimal. Just leave it as a fraction. So that's one way of doing it, doing the scale factor method. The other way is just simply to write the fact that the proportions of the lengths are the same. So 7/12 is x/3. And then, of course, you can just multiply both sides by 3 here to get 7/12 times 3 is x, and you end up with the same answer as you did down here. Okay, same answer, 36/7. So x is 36/7. So you can either deal with scale factors or you can deal with the fact that the ratios are the same. So let's go back to this here. The problem here is that we've got to work out what the orientation of these triangles is. So if we just cut our triangle like this and had this triangle, sorry, I beg your pardon, this triangle here at the top, that's our WVX triangle, and our triangle at the bottom, they're not in the same orientation. Okay, we've got to make them in the same orientation. Now, either that, or we just simply identify where the equal angles are. So we know, because these two angles here are vertically opposite each other, that these are the corresponding angles. They correspond with each other. And because we've got parallel lines here, we know we've got alternate angles, so that these correspond, and also these correspond, are alternate angles. So they're the ones that we've got. Now what we need to do now is to make sure that we get the right lengths to calculate xz. So this is our xz here. So when we do our corresponding angles, we need to make sure that these are drawn the same orientation. So think about this top triangle. What would we need to do to draw it in the same orientation? Well, we want our angle at the top to be this one, and we want our So we're looking at sort of taking this triangle and reorientating it so that it looks the same as the other one. We want our double angle here and our triple angle here. So our triple angle, in order to get from here to here, we need to twist it round. Okay, so this is our X, so we're going to turn it round, rotate it round that way, so that the X goes to the top, and we're going to also rotate it round this way. Okay, so that we get it to here. This is crap.